So question one says simplify by factoring. Notice how it says also type exact answers using radicals as needed. So we can't just fire this into a calculator because our calculator in this example here will only give us a decimal answer and they want the exact answer. So one of the things we learn in math is there's this inverse thinking, or what we call backwards thinking, if you will. So a lot of times they'll use the word inverse for that. Inverse thinking, that kind of means to go backwards. So in algebra or in math in general, if I give you a statement that says 9 plus 1 is equal to 10, you can go inversely and see this as a subtraction problem. So you can rewrite this as 10 minus 1 is equal to 9. So you're allowed to go the other direction, and you can create a subtraction problem out of this. So there's also, for every forwards thinking, there's also this backwards thinking. So in division, I could say 10 divided by 2 is equal to 5. And then inversely, you can go backwards, but if you go backwards, I have to think not in terms of division, but I have to think in terms of multiplication. So 5 times 2 would equal 10. So we have this backwards thinking. So in math, if we give you, say, 5 squared, we know 5 squared means 5 times 5, which is 25. Inversely, this is when we use the square root symbol. The square root of 25 is going to take me back to the 5. So this symbol here is supposed to have a little symbol index number 2, but over the time it just got dropped and it's just simply square root. So this symbol here is the same thing as this symbol here. They don't put this little 2 here. So again, when you look at this, what this is asking you is, again, this is what we call the square root symbol. So root kind of means origin, beginning. So what this space is saying is what root number did we square that gave me this 25? And that would be 5. So as we move forward, one of the things we also pick up on is, as far as square roots go, if I have the square root of 25, notice I can actually change 25 to its prime numbers, 5 times 5. And one thing we pick up on is, since there's a pair of 5s, what this means is 1 5 can come outside the radical in this problem. So one of the things we learn is we have kind of for each factor pair inside the radical. So for each factor pair inside the radical, bring out the factor. So for every 2, we bring out 1. So kind of, again, pair kind of implies this 2 concept. So for every factor pair, in other words, if there's 2 of the same thing inside, we're going to bring out just one of those 5s. So if I have like the square root of 36, the square root of 36 is the same thing as 6 times 6. So that's how we have a factor pair. So if we have a factor pair, what that means is we bring 1 6 out. And since there's nothing left inside the radical just drops out of the problem. So that becomes our answer. So if I want to simplify the square root of 30, if I want to do this question up here, if I want to simplify the square root of 63, I can use the calculator and go, well, second square root of 63. But notice that there's not a whole number squared that gives me 63. So we can't do the problem this way. But we do know the answer is kind of close to 8 based on that. And that makes sense because 8 squared is 64. We know the square root of 64 is 8. So the square root of 63 as an actual decimal is going to be something close to 8. So 7.9 something there. So numbers like this are going to be described as irrational. So irrational numbers, the radical will stay in the problem. So the radical will remain. And we call these irrational numbers. Now, the strategy to do this is I can take the square root of 63 by doing a prime factorization. So remember, my prime numbers are this 2, 3, 5, 7, 11, sometimes 13. So notice that 2 doesn't go into 63 evenly. That's going to be, because remember, 2 only goes into even numbers. So 63 divided by 2 is not going to give me a whole number. So the next prime number I'll be looking at is the 3. So 63 divided by 3 gives me 21. So 3 is a factor of 63. The remaining factor is 21. But notice that the 21 can also be factored with the 3. So 21 divided by 3 gives me 7. So 3 is going to go into 21 7 times. Now notice the 7 is a prime number, so the only thing that's going to go into 7 is itself. So 7 is going to go into 7 one time. So what I'm allowed to do with the square root of 63 is I'm allowed to write it as a factorization. 3 times 3 times 7. And remember, for every factor pair, notice how there's a pair of 3s. That means I can bring 1 3 outside the radical. But notice how that 7 remains inside the radical. So we have to leave that inside the radical. So our answer turns into 3 times the square root of 7. So notice how if we type into our calculator 3 times the square root of 7, it should give us the same thing as the square root of 63. But this is considered what they describe as simplified. So simplified, what we're searching out are those perfect squares. So we're going to be searching out perfect squares. In other words, we're going to be searching out those factor pairs, because a factor pair is going to be a perfect square. So again, our answer would be 3 times the square root of 7.